Hi everyone, my name is Ilya and I'm one of the GSIs for the course. And today I'm going to be walking you through the DAG module. And the purpose of the module is um, that a lot of publications or a lot of presentations will use DAGs as we commonly do in epidemiology, biostatistics, causal inference, all those courses. I'm sure a lot of you are already familiar with what a DAG is. Um, it's a directed acyclic graph that you use to kind of map out the relationships between key variables that you want to potentially include in your models or adjust for in your various analyses. So without further ado, we're going to go into the RMD, and I'm just going to give you a tour of the module that we prepared for you. So I'll share my screen here. And we will get after it. So the first part's the introduction. So this is where you'll find relevant resources that you can leverage to kind of gain a better understanding of the packages that we're using and some additional functionalities. And if you get stuck, you can always refer back to the documentation. That's always a good thing to do to double check your work. So the first package library that we'll be using is ggdag. So it's kind of an extension of ggplot. So it'll operate in a lot of the same syntax that we use in this course already. So we just wanted to kind of build upon that. And then the second package that we'll be using is diagram R. So um, I'll kind of get into the nuances between when you would want to use ggdag versus diagram R later on in this module. We just wanted to provide you resources and variations of how to kind of do things slightly differently. So you're going to have to run this package installation here. Um, if you already do not have these packages installed, as for our other courses and modules. And then these are the libraries that you will need. And I did want to also mention that you need the Daggity library. So in case you don't have that installed, you can just run this. And this will be shared with you in the RMD file. And then you will just install that and you're in business. So make sure that you run these libraries. And then the last part of the setup, which is something that I just did, I wanted to create one layer for beautification. Um, and I'll kind of get to my reasoning for why I did this a little bit later. However, this is just a trick that you can use moving forward with any ggplot graphs, where if you're going to be using kind of a same recurring theme or just a, a selection of like elements of how you wish to display your visualizations, you can consolidate that all into one layer and then just add that on to your ggplot instead of writing out all of this code. And what I did here is this beautification layer removes the major and minor grid lines, removes axes labels, axes tick marks, and axes titles. Um, and we will get to why I did that in just a sec. So now we're going to get into part one. So we're going to go over the ggdag library and how to use it. So part 1.1 is just the ggdag setup where we'll go over how to map node positions, map the arrows, and label nodes. One thing that I did want to mention here before we move forward with this is this module does not have any accompanying data set. It's not necessary to create DAGs. You don't need to use data to create DAGs. You just need to know you use it as an accompanying tool to support your like modeling framework for different analyses that you will do rather. So the first thing I'm going to do is I'm going to run this code chunk, and then I'm going to display a DAG and just a basic DAG. And then I'm going to walk through each of these pieces of code once you kind of have an image in your head of what the output looks like. So I'm going to visualize the simple DAG here. It might take a second for it to load. So this is the output for the DAG that we create using this code. So what I wanted to first show you is I created the DAG, I guess, object using this code right here, using this Dagify function. And I'm going to get into it all just in a sec. And then I ran that code and processed this object as a DAG using this ggdag function, which operates very similarly to ggplot. So instead of using ggplot, you're using ggdag to tell R to map this object as a DAG. So that's pretty neat. So let's first start with the node positions here. So I defined the node positions, which essentially are the X and Y coordinates for the nodes in the DAG, which again is a directed acyclic graph. And I use kind of standard nomenclature in our biostats and epi courses, where A is the exposure, W's, W1, W2 are kind of confounding variables, D is a collider, and Y is the outcome. So on line 68 here, we have all the X coordinates, and on line 69, we have all the Y coordinates for the nodes. And you see, I mapped them out kind of neatly in pairs, just so a user can look at this and kind of know exactly where you're mapping this to. And it's important to pass this through a list for this to work. So as you can see, that all checks out here because this kind of basic simple DAG has all of the X and Y coordinates mapped out for you nice and neatly on this grid. So you can see that A is located at 0, 0, and Y, for example, is located at 1, 0. So you can cross-check that in the code and see, hey, yeah, this checks out. A is 0, 0, Y is at 1, 0. So that's how the node mapping works, and that's how it's related to the DAG. So now let's dissect how to actually create the DAG. So what we're doing here is we're using this Dagify function, which is part of the ggdag package. And we're essentially going to go and we're going to define the edges in the DAGs. And what I mean by the edges are the arrows. So where are the arrows coming from and where are they pointed to? That's what we're going to define here. So in this example, what this means is I have node A and I have confounding variable W1 and then confounding variable W2. I want arrows from these going into A. So what we have in the output here is an arrow from W1 going into A and an arrow from W2 going into A. So that's what this code means. And similarly, for Y, the outcome, we want arrows going into Y from A, because that's the relationship between the exposure and the outcome, from W1 and from W2, because those are the kind of confounders in this toy example that we're going through. And then to demonstrate the collider, we have, we're modeling that with D, and we have arrows coming from A and Y pointing into D. So that checks out, an arrow from A to D and then an arrow from Y to D as well. And then previously we saw that there's an arrow from W1 to Y, an arrow from W2 to Y, and an arrow from A to Y. So this all checks out to the way we defined the edges here. And just to demonstrate, I'm going to add another layer here. So let's say there's we want an arrow from W1 going to W2, just for demonstration purposes. This is how you would do that. And you would just add that into your code. And then we would just rerun this. And then once this reruns, we're going to have to rerun this. Sweet. So this checks out perfectly. So now we have an arrow going from W1 to W2. So you can add arrows by doing what I just did here. And then you can also delete arrows as well. Let's say this isn't really a collider, that Y is not associated with D directly. So we can just get rid of this, and that will get rid of the arrow from Y to D. So I'll demonstrate that now. Perfect. So we got rid of that arrow that we just added, and then we got rid of this arrow. So that's kind of just how you can modify a DAG using ggDag, with how the nodes are interconnected. That's a pretty important thing to be able to do. So I'm just going to add this back in, and then we are going to move forward to the labels. So what are the labels, you may ask, and why don't you see them here? Well, that's because we haven't indicated the label code just yet. We're going to add that in a subsequent step. And essentially, instead of using the kind of the standard nomenclature, if you want to present to a non-technical audience, you can just write out the labels for and display them instead of having like these stand-in variables. So for this toy example, I just decided that I was going to make smoking an exposure. Obesity is the outcome. Diabetes is the collider. SCS is one of the confounders, and then education is another one of the confounders. And I've commented all this code for you so you can look at it. So we're basically just assigning a label to each of these nodes respectively. And then right here, we are specifying what the coordinates of each of our nodes will be. And we already did that here by creating this list, which houses them. So then you just pass this list over here into this coordinates argument, and that'll neatly map everything out for you. And then the last thing you need to do, and this is really important for any GG-DAG, is you need to tell the DAG what, or GG-DAG, what the exposure is and what the outcome is. And then just one other thing I wanted to mention is this notation, this \n, just indicates that we want to return to the next line so that smoking and exposure will be on top of one another instead of side by side. So it takes up a little bit less space. So now that we've dissected that, let's rerun this to how we originally had it. And then we'll rerun this too. And then we'll get into the fun part of this module. All right. So as you can see here, when you're kind of building your DAG, it might be a good idea to keep all these like Cartesian coordinate planes and the labels for the X and Y axes and the grid lines, just so you can get a better look of how you might want to move things around. However, once you already got everything in place, like we seem to do here, there's really no purpose in a DAG to have these X and Y labels and these grid lines. So this is where that beautification layer comes in. And I already ran this code. So we just added this beautification layer to our DAG output function, and we get this nice, clean, crisp, Apple-esque visualization that's really minimalistic. So we're really getting a nice data ink ratio here. So there's no extra content on here that can kind of distract the user from what you want to show. And this is really eloquently showing how each of our nodes are interrelated to each other. So now I'm going to walk you through some kind of cool features of this GG-DAG package. So we're going to run this code here, GG-DAG adjustment set, and that will show you all of the variables that you basically need to adjust for in your analyses that are confounders. So I'm going to run that right now. And I'm going to pass everything moving forward through this beautification layer just to kind of show the minimalistic image. So now this is a really cool thing to use for your analyses, because you see here that it will tell you need to adjust for W1 and for W2. And right here it has your adjustment set. So in biostats and causal inference, this is kind of how you denote your adjustment set. And it color coded it too. So that is something that's just like a really neat function that has a good use case, especially in epidemiology. So the next thing I'm going to show you is how to visualize the pathways between the nodes with shadows. So let's say we want to find all of the paths, and this includes backdoor pathways as well, from A to Y. So from our exposure to outcome. And we're going to adjust for the W2 node. And we're going to say shadow equals true. So this is what the output is going to look like once it loads. So it will highlight and color each of the different pathways and backdoor paths that you can take to get to from node A to node Y. So here's one, and then here's two. So that is super neat. So when you have a more complex DAG, it will lay all of them out for you. And it's just a great way to confirm your work. And then once you kind of adjust for everything, so let's say you adjusted for everything, you should only have one path from A to Y. And just a quick refresher from our epi courses, because this is a collider, this pathway is closed because the arrows are both pointing towards D. That means that you can't get from A to D to Y and vice versa. So that just shows that this is a pretty powerful tool, and it recognizes colliders and not to adjust for them as well. So now I'm going to show you how to visualize the pathways without the shadows. I personally would recommend to use the shadows because it shows you how all the nodes are interrelated to the other nodes. Whereas here, it just shows you the pathway of only kind of the existing nodes here. So I would recommend to do it this way. However, you're more than welcome to also, check it out and use this as well. The only difference between this code is that we have shadow equals false here, and then shadow equals true here. So now let's visualize the DAG with using neat labels. And this is kind of what I was alluding to earlier when we set up the labels in our code during the initial DAG setup step. So this is what you'll need to do. First, you'll need to say text equals false because that says to R, do not use the A, Y, W1, W2, and then D, and use the labels instead. And the labels, just as a reminder, were outlined here, right here. So that's where the labels comes in. And this is the output. So it kind of wraps the labels nicely so it doesn't interfere with the DAG itself, so you can kind of clearly see where all of the arrows are pointing to. So now we're going to get into part two, which we're going to use a combination of DAGity, which you guys have probably heard about in your epi courses, and ggdag. So what we're going to do here is we're first going to navigate to the Daggity website. We're going to create a DAG on Daggity, and then we're going to copy the code that Daggity outputs for us. And I did want to stress that a good use case for using the Daggity website is when you're kind of in the exploratory analysis phase of your kind of data science work, and you're playing around with a lot of variables, and you want to see how you want to best visualize them. Daggity is a good way to do it because you can just do it using point and click methods. So I'm going to stop sharing that screen, and I am going to navigate to Daggity. So now that we're in Daggity, we're gonna launch it. So click on launch, and it usually brings us to this kind of generic looking like DAG. And I'm going to walk you through just kind of how to use this in a very simple way to reconstruct the DAG that we were just using. So here, what I'm going to do is I'm going to rename this to A. So I'll click on this first. Now you see it's highlighted. Then I'll go to rename. Then I'll just rename that to A. Variable already exists. So let's rename this one first. Rename to W1. We're going to get rid of this because we don't have any mediators in our analysis. So we just click on that, delete that. I'm going to remove that line, and I'm going to click on this. And the way you make an edge, so first you click on the node, then you have an arrow. You click on the node you want it to be pointed to, and it'll create the arrow and form the association here. So now let's rename this. We're going to click on this. We're going to go to rename. I'm going to rename this A for the exposure. This, we're going to rename this to the outcome. So this will be Y. We'll rename this to W2. And then now let's add one more. So you just click in the space, and then I'll add a new variable. We're going to call this D for the collider. So we'll just put that roughly somewhere over here. And then we'll make, sorry, we need to remove this edge. We're going to click on this one first, and then we're going to add an arrow. Then we're going to click here, and then we're going to add an arrow. So now that you move these around, these arrows are all interconnected, whichever way you might move them. So let's move this a little bit closer. And let's turn these into real confounders. So now we're going to click on here, and then have an arrow going there, and then take this and have an arrow going here. So let's see what we have here. So this, we need to get rid of that selected here. So this basically shows you now that you have this red color, red pinkish coloring is showing that this needs to be adjusted for because it's a confounder. And same thing here. And then the green is showing the relationship between the exposure and the outcome, which we want to isolate by adjusting for these confounders. And these black lines indicate that, hey, you don't want to adjust this because, hey, this is a collider. So we see that Daggity also kind of has some of those features too. So now that we've kind of roughly reconstructed that DAG that we already had, we are going to look at this code here. So this is code that you can copy and paste and put in R. So I'm going to copy this and I'm going to go into RStudio and I'm going to take this old code that I had, and you want to make sure that you take that code and you paste it into here within these quotes. That is a key for this to work. So I took that code and I'm going to create a new DAG with it, and then I'm just going to run that DAG and add some beautification to it. So I wrapped that function or this code essentially inside Daggity, which is the Daggity package that we're using, and we're mapping this to the DAG object. And see, there you go. Now we have the DAG that we created. And two things I wanted to point out. So for some reason, like everything's flipped upside down. And I don't know why that's the default. However, all the variables are still related in the same exact way. So it doesn't really matter um, the orientation, how it's oriented. And the other thing I wanted to point out is we can see here that it'll take the code at exactly the positions that where we clicked to insert a node. So it's not necessarily the most precise or symmetrical. So what you can do is you can manually go in and just change these so it aligns in a more clean and symmetrical way. So the way that you will do that is you can just go in and just type it, and I've retyped them here myself. So I also included this kind of just regular text outside of a text box, just so you can see what each of these lines of code does, because this really isn't in the R language. So we can't write a comment here, for example. See, it follows the code. So I wrote line by line comments out here just to kind of walk you through what's going on at each step. So essentially, this first step is just node A. We're indicating this is the exposure variable and its position. That this is node D and maps its position. Node W1 maps the position, and so on. So what I wanted to point out here is Just like with ggdag, you want to, or with Dagify, you want to indicate what your exposure and outcomes are. That's very important for it to know which variables um, like need to be adjusted for. And yeah, this is the way that you would do the arrows. So you just straight up write, I want an arrow pointing, a directed edge pointing from A to D, and then I want one pointing from A to Y, and so forth. So slightly different syntax than using ggdag and Dagify. However, it's pretty simple. So this is where I manually adjusted for the coordinates for visual symmetry. And there we have it. So this looks nice and neat. Everything's aligned, and um, we've successfully taken a DAG from the Daggity website, imported it into R, and then without having to really code a whole lot, and then modified it just so it lines up. So now we'll get to part 3, and this is using the diagram R package. And once again, I wanted to note that even for the simple DAG, this isn't really our code, so we can't even write a comment here. It just doesn't register it as a comment. So under here, I also I'm going to walk you through line by line what this code does. So basically, I'm going to just I'm just going to run this. I'm going to show you how the visualization looks, and then I'll walk you through the code step by step with the comments. So what you'll see here with Diagrammer is that it's a very minimalistic package, and this is oftentimes a really good use case for a journal publication where they want you to have a simple black and white representation of your variables, um, and it's just like a nice, clean way to communicate things. Whereas in ggdag, you can add all the color and like adjust for do those adjustment functions, stuff like that. This is mainly like when you have your finished product, you want to put it in a journal. This is a good avenue to go. This package is a good avenue to go down. So I'm just going to walk you through the code right now. So anytime you run anything through Diagrammer, you want to use this kind of, you need to say that I want to use this package. This is the notation to do it, and I want to use this grviz function. So then you would have to use quotes, and then you would essentially just have to follow this exact same layout that I have, and then you would just kind of change your nodes around, and I'll show you some other tweaks as we kind of go chisel away at this. So this right here represents the vertical distance between the ranks in each graph. And the ranks are located here. So this is like rank 1, this is rank 1, rank 2, rank 3. So that's the vertical distance. How far do you want to elongate those edges? And then for the nodes, I've indicated here, I've set the shape to plain text. So this is, I just want it to display the text kind of as is. And then here are my nodes. So A, Y, D, W1, W2. So very simple. We're just defining the nodes. And then this right here is the function to set what you want the minimum length of your edges to be. So instead of it being like, so it's just how big or small do you want the distances to be between your edges, between your nodes. And then this is how you create the edges. You just select the node and you point an arrow in the direction to the node you want it to be correlated to. So that's how you do that. And then right here, this is very similar to setting that node A is the exposure and node Y is the outcome. We're just specifying that A and Y should be on the same rank. So going back to rank here, that it has to be at the same level. So it's nice and clean and nice and clear that this is your outcome, and then this is your exposure, and this is your outcome. So it's all on one line. And then everything else is kind of floating around in a different space at different ranks. So now that we have that, let's add the node labels and just kind of develop this a little bit more. So this is how you do this. I just added a label consistent with how we did it in the past. A is smoking, Y is obesity, D is diabetes, W1 is SCS, and W2 is education. So let's run that. There you go. So now we have text, and it's pretty clean output. However, it could be better. I wouldn't say that this is publication ready yet. So a next step that we can do is modify the node spacing. So what we're going to do here is for this rank separation, we're going to bump this up from a 0.2 to a 0.4. So right here, we currently have 0.2, and we're going to bump that up to 0.4. And this should kind of elongate the graph vertically. See, and it did exactly that. So now the spacing looks a little bit better. It's a little bit more crisp. So it's getting closer to a publication ready graphic. However, I want to tweak it just a little bit more. So what we're going to do for this next step, we're going to modify the minimum edge length. So we're going to go from 2 to 4 here. And let's see how this output looks like. Sweet. So now we have a very kind of long, wide version of this graphic. So, I mean, it's really up to you what you kind of want to depict. And there's a lot of journal preferences and preferences of your audience, however they want to see that. So it's important to know what they're looking for. And the most important part here is that you can add boxes to indicate your adjusted variables, how we do in our epi biostats courses. A box denotes that we're adjusting for this variable. So you can just add an argument called shape equals box to any one of these nodes, and it will show that it's adjusted for. So there you have it. This is now a, um, I would say, publication ready DAG, um, where you have a user or anybody who's looking at the DAG can look at this and know exactly that, yep, these are your confounders, you've adjusted for them, you're trying to isolate the association between smoking and obesity, and then you have identified that diabetes is a collider, so you are not going to adjust for it in your analyses. So that concludes the DAG module. Thank you so much for watching. I hope that this was valuable and you learned something. All right. Have a nice rest of your days. Thank you.